Good morning. We are going to go over chapter 9, lesson 7. I know yesterday you guys did 9-5, which was on combinations. We are skipping 9-6. It's kind of just one of the lessons about other strategies to use, which I've kind of been telling you guys throughout. So just to keep going forward, so we can hopefully finish this chapter before you guys have spring break. And I'm not going to give you any work over spring break because I know you guys need a break as much as I need a break. So chapter 9, section 7 is on theoretical and experimental probability. So we're still talking about probability. I know those are a little bit of big words, but I'm going to break them down for you. So these are the definitions. I would suggest writing these down if you brought your math notebook home with you, or just jot them down on an index card or something so you have them in front of you when you're doing your homework, so you know the difference about which one is which when the questions ask find the theoretical or find experimental or find both, so you know which one the question is asking you to find. So the theoretical probability is what should happen when you're conducting an experiment. So we're going to go over a couple examples of both so you guys have an understanding of them. And then experimental probability is what actually happened during the experiment. Okay? So looking at this first example, this is on experimental probability. The first question says that 2 number cubes are rolled 75 times and a sum of 9 is rolled 10 times. What is the experimental probability of rolling a sum of 9? So this is different from what we've been doing as far as trying to find out how many combinations there are, or the patterns, or the permutations. So this is actually a little bit easier if you're pulling the correct information from the problem. So if you're reading the question, it says, what is the experimental probability? So this is what actually happened in the situation. And it's asking what actually happened when you rolled a sum of 9. So over here is kind of a breakdown of the formula that you're going to use, or kind of the setup of how to find this. So remember, with probability, I mentioned in the last couple of videos that probability is always going to be in fraction form, because it's talking about how many out of the whole number. So in this example, I'm trying to find P of 9. All that means on this side, when you guys are seeing that, is finding the probability, and then I'm finding the probability of the sum of 9. So it's just a shorter way to say what you're trying to find. So breaking this down, the top part of my probability, or my fraction, is going to be the number of times that the sum of 9 occurred. So looking back at the question, it says the sum of 9 is rolled 10 times. So that's going to be my top number. And then the total number of rolls, and again, looking back at your question, it said that the 2 number cubes were rolled 75 times. So 75 is my total number. So you guys can see that on the screen. It's kind of already written out for you. So I have 10 times over 75 rolls. And then remember to always simplify. So when you simplify this, I know that 5 can go into both of these numbers. So I would divide both by 5 and simplify to get 2 out of 15. So it's really just pulling out the correct numbers from the problem. Don't overthink or think that you have to use every single number that's in there. I know it's talking about 2 number cubes, but it really doesn't matter how many number cubes it is. I know it's talking about the sum of 9. That's just what you're finding. You're not using 9 anywhere in your problem. Okay. So looking at the next question, and this is dealing with the same scenario that we just talked about. So it was asking for you to find what the experimental probability of rolling a sum of 9 was in the last question. So this is an extension question. and it's asking what is the experimental probability of rolling a sum that is not 9? So when you're looking at these questions, and I know it's been a while since we've done the cube strategy, but underline or box in, circle, whatever makes most sense to you, those keywords. The word not is super important in this problem. So when, in the last question, when we were rolling a sum of 9, you found that there were 10 times that happened out of 60, or out of 75, sorry. So the sum of not rolling 9 would be 65. The way that I found that is there were a total of 75 rolls, and 10 of them was when 9 occurred. So I would just subtract the difference, which is 65. So then the sum of not rolling 9 would be 65 out of 75, which you can see right here. And then again, simplifying it, 5 goes into both of those as well, which will simplify to 13 out of 15. Okay. And looking at another example, and these are all examples that are in your textbook. If you have it, I know not all of you brought your textbook home with you, but they're in this section if you want to actually look at the graph and look at these questions. I tried to remake the graph as best as I possibly could on here. So it says, the graph shows the results of an experiment in which a spinner with 3 equal sections is spun 60 times. Find the experimental probability of spinning red for this experiment. So if you look at the graph, and I know it's hard to kind of see, not every number is given. They're kind of by fives. So green was spun 21 times, blue was spun 15 times, and then red was spun 24 times. So in your book, it shows that a little bit better if you have it and you want to look at that. So finding the experimental probability of spinning red. So looking at the graph, and again, I know it doesn't show it very well, but it spun red 24 times, which is right here. Oh, sorry, guys. So I have 24 right here. And then the total number that it was spun was 60. So that's going to be my bottom number. So I spun red 24 out of 60 times. And then I'm going to simplify that. 12 goes into both of those. So I can simplify my final answer to 2/5, okay, or 2 out of 5. So for every 5 spins, 2 of them would have been red in this situation. So still using this same example and talking about theoretical probability. So you are going to compare the experimental probability you found in the previous example to the theoretical probability. So remember, experimental was what actually happened, theoretical is what should happen. So looking at the screen right here, it says the spinner has 3 possible outcomes. So there was a chance of it that it could land on red, blue, or green. So the theoretical probability of the spinning and landing on red would be 1/3. So there are 3 colors, only one section would be red. So the theoretical probability, or what should happen, is that for every spin, I have 1 chance out of 3 chances of landing on red. So the question is asking for you to compare. So there are kind of 2 ways you can do this. If fractions are easier for you to think about, that's fine. I'll show you a second way that's at the bottom of the screen in a minute. So it says, since 2/5, and where I got 2/5 was the last screen, since it was talking about red, you want to make sure you're comparing the same thing. I'm not comparing red to blue, since the last question was talking about how many times it would land on red. I need to be comparing how many times it would land on red in this question as well. So I have 2/5, and then the kind of curvy equal sign is that it's almost equal to 1/3. So the experimental probability is close to the theoretical probability. So that is your answer, is just comparing the actual fractions or the actual probability. So in the last one, it was 2 out of 5. On the theoretical, it was 1 out of 3. So they are close to one another. Another way that you guys can see this, I know fractions are kind of hard to look at and determine if they're close to one another or equal to each other. So looking at the bottom of the screen, another way that you guys can do this is by actually dividing the fraction out to find the decimal. So if you're actually dividing 2 by 5, when you divide that out, it would be 0.4 or 0.40. And then when I divide 1/3 out, it would be 0.33. So they're not exactly the same, but they're pretty close to one another. So when you actually divide them, you can see that they're closer. You could also make your fractions have a common denominator if you want to compare them a little bit better. So on this, I know that 2/5 and 1/3 could have a common denominator of 15. So if I were to take 2/5 and change it to a denominator of 15, I was multiplying 5 times 3 to get there. So on the top, I would do that as well. So 2/5 would be the same as 6/15. And then on the other one, if I'm changing 1/3 to 15ths, I'm multiplying by 5. So this would be 5/15. So you can see now 6/16 versus 5/15. They're really close to each other. When you do it this way, they're actually only 1 off from each other. So it shows you how close they actually are. So whichever way is easiest for you, if you need to divide them out to make them decimals to show that they're closer, or making a common denominator to show that they're closer as well, whatever works best for you. Okay. If you have any questions on this, please let me know. Please reach out to me. I am more than willing to help you with this. This goes along with the page 147 and 148 that you guys have to work on. There are examples and kind of a breakdown of how to do these on there as well. So if you need additional help, look at that. You can get on quizzes and find some questions that go along with this as well. If you want extra practice with it, you can get on Khan Academy and do extra practice with it as well. I will be more than happy to help you in any way possible. I hope you guys have a great day. You only have 2 more days until spring break, and I know we all need that break. So have a great remainder of your Tuesday, guys.